Thank you very much. Last presentation of the day. I hope you still have some energy to watch and don't fall asleep. My name is Roland Reyer. I'm a so-called technical specialist at Autodesk for the media entertainment solutions, which means for Maya. So I'm the demo guy, basically. And today I would like to talk about something that has to do with Maya, of course, and with Bifrost. So Bifrost is the procedural or the visual programming part of plugin for Maya. And this Bifrost lets me do various things coming from, particle simulations to smoke simulations, fire, and all these special effects, but also lets me create polygons, for example. So which is something that is not very built up yet, but you can already do it. So I try to build something in Bifrost, so make a compound pack for all the users that lets you use a very specific thing that I've seen in a presentation by a guy called Maxime Jean-Mougin. He was a technical artist at Platinum Games in Japan, and he is now a colleague because Autodesk hired this smart guy for a good reason. And he was showing last year on the GDC, he was showing in a presentation something that they made at Platinum Games with Bifrost because they wanted to stay in Maya. There's something that you could do in Houdini and was done in Houdini already, but as I said, they wanted to stay in Maya, so they used Bifrost to rebuild the same thing. And what I saw there was, oh, this thing is not going forward, but never mind. So what I saw there was that they use a construction history kind of thing in Bifrost to turn this simple block here into a complete building like this one over here. And he showed lots of different examples and so on, and I thought, man, I want something like that. But of course, he cannot share this stuff. It was done at Platinum Games. It's their asset, so he cannot pass it around. Actually, what he said in his presentation, that the main idea for this thing came from Akira Saito, who works at Polyphony Digital. And this guy is a Houdini artist, and he is, the Polygon master in Houdini. And he invented a system to, subdivide blocks of simple Polygon blocks and subdivide them and work on them so that they look like buildings. And when you look at this cityscape here, there are only 3 types of buildings here. So there's this white one with a little detail here at the top, which is over here, which is over here, and even the small ones is it. So this white building is everywhere. Then we have the one with the gray strips here, which also is here and here and here, everywhere around like here. And there's a third one. So it's only 3 types of buildings in this whole city here, which, after a while of looking, you realize it, but at a short glance, wow, this works pretty well, having, given the fact that you only have some cubes to place in the city, and then, you can populate the whole thing with balconies and windows and everything. So how is that made? It's basically a construction history. And this is now already, this is my stuff already. So I rebuilt this building from Maxime that he showed in his presentation, which is actually a real building. In New York, you will find this building at the south of Manhattan. It's a so-called Washington building. And this construction history that we have here builds from a simple block, makes this in, in a second or so per block. So you can have a few blocks and, within a few seconds you will have a whole cityscape. So it's a construction history. We know construction history from Maya, so we know already, even in 3ds Max, there's a construction history, and we know how this thing works. The problem here with the construction history in Bifrost or in this workflow is that you cannot point at things. You cannot say this face is going to become the roof, or this face is going to become the west side of the building or something. You have to do not only the operations in a procedural way, you also have to do the selection in a procedural way. I mean, that is the case why in Maya, for example, if you have a construction history and then you plug a different starting object into it, it changes everything because you pointed at faces that are completely somewhere else in the new, in the new construction history. So that's a big disadvantage, or, you know, something that's holding us back to go more with these construction histories, because this selection thing has to be procedural as well. Currently, it's, you know, the best application is for architecture. It's simply, you know, subdividing the buildings horizontally and vertically, so that you end up with a skyscraper kind of building, a modern building, let's say. So anything organic or so is currently not possible with this workflow. And we can, you know, think about other construction history types in the future, but at the moment it's going to be architecture. What you see here is, you know, this is my testing object here, and I built a number of nodes. And the first three of these are the most important ones. I'm going to use that all the time. So there's a multi-cut node that cuts polygons horizontally or vertically into strips. And then you can select these strips or some of these strips and say, okay, I'm gonna cut those in the other direction and make more detail, like windows or something like that. And you know, the first three, as I said, you know, multi-cut, extrude, and instance to place, you know, more complex geometry into these windows here, for example. These are the most important ones. And then what you do, you use these nodes or these compounds that are built. I mean, it's just a container for a more complex program. And you use these and chain them together in a construction history, which would look like this one here. So the one on the top here is a complex building, and this one here is the Washington building that you've seen already. It takes like 20 minutes, maybe 40 minutes to make such a building, but once you have that, and it would be, you know, in traditional modeling, it wouldn't be instant. You know, you also take some time to subdivide things and to you know, think about how do I subdivide that building to end up with all the polygons that I need. So this is a similar workflow, but once you have it, this recipe, you just plug in different starting objects and rebuild that building. So now we come to the selection part of the whole thing. I used something I call face tags here to name these polygons. So all of these polygons belong to a certain name. Every polygon can only have one face tag. So that's different from the component tags in Maya. The face tags are exclusive. You can only have one face tag per face, which makes the whole thing faster, by the way, and easier to program, etc., etc. But I mean, we can change that in the future. You can start with component tags now that my Bifrost 2.7.1 is out. You can start with component tags and convert them to these face tags that I'm using here. And then you can set these tags and you can get the text. So for example, you know, give me all the faces that are labeled window here, for example. And then, you know, select a random number of these windows and give them a different name, like, you know, these different colors here. Like 50% of all of these windows have been selected randomly. And then select from these random windows, select all the ones that are in this wireframe box here. So this kind of selection is procedural enough. I mean, placing a box somewhere is not very procedural. You know, once you have a different starting geometry, then, you know, your box is in the wrong place or something like that. So the safest way would be to select by normal. So that is something that I was very successful in using. And with that, we're going to make some example here. And I need this closer to me. That's okay. It's okay. Works like that. So I want to make some example here, and yeah, the selection node. And the example is going to be this thing here. It's a balcony that I built from a single polygon. So, and I think this example here is simple enough to explain you the basics of the whole thing. So let's jump into Maya. Here's my balcony already. This is what it's going to look like. And it, as I said, it starts from one simple polygon. So let's remove everything here and start with a simple polygon. It's just a polygon plane. I'm going to make it bigger and I rotate it. So my forward axis is the Z axis. So I rotated it around X. like so. And then in the construction history, I go and do this height baseline here and turn the subdivisions down so that we have one polygon. Now when I create the Bifrost graph, you see that there is one input already as an object. I feed this into my output and hide the original polygon plane. So what we see here is now the Bifrost polygon plane. Okay, which still, oh, I think the rotation here has gone somehow wrong. 90 degrees, and the rest should be 0. Okay, so it still depends on this polygon, on this original polygon. I can even play around with the original polygon, you know, and rotate it, for example, and scale it up and down to see, you know, if my procedural thing is working okay. So what do I do now? How do I start? So I start with a PPG multicut node. PPG multicut, as I said, that's the basic or the most used node here. And you see nothing happens. All of these nodes have these, and most of these nodes have both sections, but all of them have this first section here, the face selection. We need to procedurally select which faces are we working on. There are no face tags there yet, so I do a simple trick and I put in an asterisk, a wildcard to say all of the faces. It's only one face there, so pick that one. And now we have some subdivisions here and a red arrow, and we can play around with the values here and don't understand what's going on. So what does this thing do? One problem that we have here with these face tags is that after a while you don't understand anymore what it is, what it does. So I wrote another compound which is called PPG Diagnostics, and it creates colors. It colors these strips depending on the name, and it labels these strips with these face tag names. Because after a few operations, you would be completely lost. What is what in my model here? You would have to make a drawing. With this, it's much easier to see, you know, what we have. Now let's go back to our PPG node and see what we have. We have obviously some outer and inner strips here, and they alternate. These two components, you know, we have something that is outside, and then, you know, a strip, and you can define which ones of these have a fixed size. So, for example, when I change the outer size, and make it bigger, you see that the inner size is somehow squashy. You know, I'm not touching the inner size at the moment, but it moves somehow because it's the flexible one. We can see that here on this attribute, it's the flexible part. I can set the outer to be flexible or the inner one. And that means I calculate the whole width of the polygon, and then I say, with this outer and inner sizes, how many subdivisions do I have? And if it's not an even number, you know, the flexible part has to grow a little bit or shrink a little bit to help me get this even number of subdivisions done. Okay, so the outer, the inner is now flexible. We have to unhide this original polygon a little bit to understand what this red arrow is doing or this edge selection is doing here. Currently, I'm using this direction vector to select this edge down below here. So I'm looking from the center of the polygon downwards, and the edge that I find there, that's the one that I've selected. And why do I need that? So when I pick this vertex here at the corner, and move it around, you see that we get more subdivision if this edge becomes longer. Okay, and when I pick this one here, it's not going to subdivide because that's not the chosen edge. It's not the selected edge. I have to select one because not always are the polygons, you know, quadratic or even rectangular. Sometimes you have polygons that are, you know, different shapes. You have to choose which edge you want to subdivide. And this edge is subdivided using real-world units. So when you scale the block of the original polygon, you're not going to get a smaller building with smaller windows and smaller balconies. You're going to get a building with less windows and less floors and less balconies. That's the whole point here, right? So we have to define which edge we are subdividing. I can say I want to pick the next edge, which will then, you know, instead of this one over here, counterclockwise, pick the next edge, which is this one here. And then I can say, hey, actually, I just want to have a fixed number of subdivisions, one subdivision, for example, which leaves me with this outer strips, because the outer strips have the fixed size, and the one in between, the inner part, is flexible, right? So that way I can subdivide a building and say, okay, something is flexible here, and some other parts, you know, need to subdivide whenever I stretch it, whenever I overstretch it. I could say, you know, this building here has a side wall with just a small strip at the bottom and at the top, and when I scale it, you know, the middle scales with the whole building. It's stretchy. So these are these settings here at the beginning. The edge selection, we can also select the longest edge or the shortest edge, for example, or simply start at a fixed index. And with next edge and opposite edge, I can wander around and say, generally, I mean vertically down, but then +1 or +2 or +3 to select the edge that I want to subdivide. And as I said, you know, I played around with it, and all these options came after a while, you know, because I needed somehow to define everything we have. So we wanted to, remember, we wanted to make this balcony thing, and actually for the balcony, I just need the lower strip to extrude it out to get the base platform for my balcony. So what I need here is to say fixed subdivisions, that's right, one subdivision, and then I don't want, you know, my outer on both sides, so it's not going to be double side, it's going to be just at the start side. Here we go. Now there's my base for my balcony platform here. A word on these names here, the face tag names, they inherit the parent name. That's why we have this underscore here with an empty parent name at the moment. So we can turn this parent name off and then simply say, okay, the outer is my B, my balcony, and the inner one is my A, that's my apartment. And you see that the colors change. These colors depend on the face tag name. I made it so that, you know, the colors change as little as possible. I don't want, you know, at every step all the colors change. The colors will remain as long as the names are the same. Good. Okay, so let me turn off here this red arrow here, this feedback or this diagnostic display. And then my next node here is going to be a PPG extrude. I want to extrude this balcony thing out. Nothing happened so far because I have to define, oh yeah, I want to extrude the balcony. Here's my extrude already. Then I set a distance for the extrude. The extrude node is a little bit more simple. There's no edges to select. So here's my balcony. And what about the names? The sides of the balcony I call, the extrude itself I call front or something. Right, that's this one here, and the sides of the balcony I still call B for balcony because I'm going to go on with that, and I like to make the names as short as possible. I don't want to type too much. Okay, the next step we want to take that plate here, that polygon that is on the top of the balcony, and we want to subdivide that one. But here comes the selection problem. We need to select it, and for that I have made a node called select faces by normal. And it also, this select faces by normal has an input face selection. And this is set by default to wildcard, so everything from all the faces, all the face tags I'm going to select by normal. But no, in this case, we want to select from the B, from the balcony polygons, all of these ones here around. And you see, this one is already selected. Yeah, because our normal is set to, you know, Y up. And that's the only polygon that has a Y up orientation here. Let's call this one top. Maybe it gets a different color. Yeah, that's fine here. You see that the sides are not selected with this goal value. The goal value is actually the dot product between the normal and the vector that we are giving here. So I can say I want the ones that point to the side. So instead of this normal here, I don't want that one. I want the ones that point to the side or maybe to the opposite side. So with this goal value here, if I set it lower, then suddenly you see that the sides are going to be selected here. with 0. It's the cosine of the angle. With 0, I get the ones on the side, and with -1, I get the ones down below. Okay, so we set this back to 1 to have this top selected here, and with the top selected, I'm going to make another PPG multicut. And the one that I want to cut now is the top. Here we go. In a different direction. Oh, we are selecting downwards now. That might not be right. So as soon as I tilt this initial plane a little bit, this whole selection is not going to work anymore. I need to select in this direction to select the, the edge here. So I'm going to say not downwards, but in plus Z, I'm going to select, and now you see the red arrow here. That's selected correctly. But the next edge, and I want just one subdivision, and I want just the start. Okay, so that's the part in my direction, which, that's the part of the balcony that faces us here. And it's top outer, yeah, why not? So I call it O, and the other one is still top. Maybe top. Ugly. Let's call it T. Okay, in the next step, I'm going to do a PPG. It's a little bit boring after a while, because you need to have these multi-cut operations, and it's not like, repeat the last operation like in Maya. You just click on a face and repeat it. You have to create these nodes and input the names. So here we have the top underscore T. No, that's the German keyboard, underscore T. And I also want to subdivide the top underscore O. Why is that? Because I want to cut off both sides of this balcony thing here, which would be just one subdivision, okay? And I also want to have this square thing here at the corner, because I'm going to place some posts for the balcony rail, some bigger posts there, which is an instance node. So I need those as well. So, and again here, so I call this O and the other one I, just to make sure that it's, it has these names here. And for these names here, top O underscore O, I'm going to do the the instancing now. So I turn off the diagnostic display here. And, one thing that I keep doing is to move these diagnostics to the right, to the right, to the right, because I'm making more construction history. So now we do the instancing. It's called PPG instance. And at first, it does nothing, of course, even if you put in the name. So we want the corners, which are called top underscore O underscore O. And look what happens here. They disappear. Because the instance was initially made to, place an apartment, some balcony, for example, or some complex windows or some arch windows or so, to place something like that in place of a window polygon and remove the window polygon. So by default, it deletes the window polygon, which is this tag down here. We can turn this off and get our polygon back. And you see on this polygon, there is a little coordinate system with the z-axis pointing upwards. That's our instance. Hey, and let's put in some instance. I'm going to create a mesh cube here, and that's the node here. And I copy it and paste it 2 times because we need more of those. So this cube here will be placed on the corners. Here's my cube. Wonderful. So now I need to only scale it, and with the instance, with the single instance, I can scale the cube from here. Here are translation, rotation, scale properties to do this, right? So we want to scale it in Z, and how many units do we scale it? I would say 5 units, and then we need to move it upwards by 2.5 to be there, and I can scale the other 2 axes to make it a little bit, a bit smaller. It's too big. So here are my first instances. Turn off the diagnostic display. The next instance is, you know, all the supports for my handrail along the polygon. And I had to write an extra note for that because with the instance node, I wasn't happy with the whole workflow here. So I created a PPG multi-instance, similar to the multi-cut. And this multi-instance, when I put in the names here, it's called top_OI. Top_OI. I wish I could click on these things. And the other one is top_TO. Top_T_O. Imagine you would have to remember all of these names. So what happens with the multi-instance? Look, it creates a ton of little coordinate systems along this polygon. By default, this multi-instance is set to choose or select the longest edge because, you know, I want to place a row of polygons or a row of instances there. So longest edge makes the most sense. And so we just pick one of these cubes here and plug it in. And there are my multi-instances along this thing. With multi-instances, there is no way to scale them from within the node. We only have these random translate, rotate, scale values to make them random somehow if you want to have them jiggly or so, or rotated randomly, for example. Besides that, you do that in the instance itself. So the height, for example, we can scale the height. How much should we do? The other ones are 5 units, so I do this one here, 4.7 maybe. And then have to move it up by, in this case, the Y translation is the up that we need here. So I need it to 2.35 in up direction. And then I need to scale these. So width and length. Undo width and length together. No, it doesn't like me. Wrong key. So here we go. Small supports for the whole thing. And in the multi-instance node, you will find this distance here. This distance defines how far these instances are apart, which means you set the number, you set the distance in real-world units, make the whole thing bigger, and you get more of these supports here. There are other values. So, for example, here, this first one is a little bit too close to the big support on the side, and I have a value called side space that moves it away from the side of the polygon, making shorter this whole distance where it can place instances. Okay, that's fine. And then to get the handrail done, I'm again using a PPG instance node with the last cube that I have over here. But this one is a little bit special. Yeah, so let's put it in. And I don't know if we can see that already. Oh yeah, I have to, of course, I have to use the same names as this one here. So I simply copy and paste the names over. They are a little bit cryptic already. So here you see what it does. It deletes these, turn off these diagnostic displays here. So it deletes the faces again. I have to do, to set this flag here that it doesn't delete the faces. But there is a problem. Look at this here. We have here one of these red arrows and another red arrow over here. So they are pointing in the wrong direction. Why? Because multi-instance is automatically choosing the longest edge. And instance is using a direction vector because it's made for buildings, for the facades. It says by default, vertical, I'm looking downwards to select an edge. So in this case, I have to set it to longest edge here to choose the right one before I start to even, place these, place these using the translation, rotation, scale. So the z-axis was the up axis. So we placed this upwards. What was the height that we need here? 4.7, right? 4.7 was the height of these things. And then we scale it long, which doesn't work here. So it says scale uniformly. So it scales the whole box so that it fits into the polygon somehow, but it scales it uniform. So which one is the shortest distance, and that is the scale for this thing here. So scale uniform needs to be turned off, and then it stretches the whole instance object so that it fills the whole polygon, right? So it fills the polygon in this y direction here. So, and we have to scale it down, I think, in these two directions here. No, that's not right. It should be this one and this one. So here's my handrail. And there was a special problem, and I had to chew on that for quite a while. So here we see that because this polygon is shorter here, and it fills the whole polygon with this instance, we have a gap. And I don't like that gap. So for the children, it's better, you know, gapless. So let's scale this in the one direction here that we are having. So this is the X direction here, and I hold the control key to fine tune it to, you know, just plug it into the side. Problem done. Until I scale the original underlying polygon here, my polygon plane. So I scale it and make it shorter, and suddenly look, what happens here? Suddenly we have this gap back. Yeah, of course, scaling is a relative thing. I scale a big thing, that's, you know, that scaling factor gives me a big distance, and then, you know, relative to the small thing, that's only a small distance. That's not enough to reach this big pole at the end. So I need a different scaling method to make this here. So I set this back to 1. So we have our gap back, and that's this at scale in units. So I'm calculating the scale that is necessary to reach a certain distance in units. And by doing that, I can, you know, put it into the side here. And now when I scale the underlying polygon, it works okay. So there's no gap anymore. Complicated things sometimes, but now you see we have this polygon here, and we can scale it around, and the handrails, you know, magically re-subdivide itself and make more or less of these things. And the other one, you know, there's an extrude at the very beginning. When I change the distance, it's the same thing, you know, with the supports on the side. So it seems to work. So let's make some final steps here for this whole apartment thing. I'm going to make a PPG multicut with the apartment, with the apartment polygon. So I'm going to subdivide this one, but only once. And I want to give the names here. So the inner one is still the apartment, and the outer one is side. And I call all of these side pieces side because that's going to be a wall material. So now I'm starting already to say they can have all the same tags because they will have the same material in the end. So we need to think about the material assignment as well. So the next thing here is a little extrude, PPG extrude for the A polygon that we have here. It's hard to select A polygon. And we want to extrude inside. What we see here, what's gray here is my original polygon plane. I hide that one. So here's my polygon, and I extrude it to the side. And again, no name inheriting. This is still my apartment, and these are the side polygons, very much like the other ones. What's wrong? Side. So the pink ones. And now what I want to do, so what I envision is to subdivide the whole thing in the middle and say one is the door and the other one is the window, but we also need to do some frames around the windows, around this glass material. So it's going to be a PPG multicut. And actually there are plugins where you can have a node chooser here on the side in the editor where you can have this group open and just click on the various compounds so that you don't always have to type things here. I'm going to turn off the diagnostic feedback here with the red arrows and stuff because it's going to make us slower. And this one here is going to work on the polygon A again. It will be only one subdivision and I make it at the start side. And I want to one side is going to be a fixed size here. So in this case, the fixed size would be the left size, the outer one here in this case. I can say I want the door on the right side, and so I need the flexible part to be the outer part. And then, I define the whole size with my inner size here, which is now the right side. And the name's going to be, the outer is going to be window, and the inner one is going to be the door. And here comes the trick now. Now we want to subdivide the window as well, but vertically. So PMC for PPG multicut. And we are working on the window now. And I want to cut vertically, just one subdivision, only at the start. I can also make the end side so that, my window will be the fixed size. That's the outer. So my window, so this upper thing here, that's going to be the fixed size. When I resize the polygon, this window will have the same shape. And again, now I start to make these decisions about the material again. So the inner part is side, because that's going to be the wall material, and the outer one is going to be window again. In the next step there, I will put them both together. So this door and the window will be extruded together. So in the extrude, I'm going to set the name to win and door. So both of them are extruded, but not with, coming out here. It's going to be an offset. So the offset is going to be negative, so we make some frames here. And again, so the extrude faces are called glass from now on, because that's the window and the door are both glass doors, and the sides are the frame, the door frame. And there's just, just one more extrude here, PPG extrude, and we can say this is the glass again. It's so hard to pick here. The glass again, and in this case I'm going to extrude inwards. Again, the names are going to be glass and frame. Ta-ta! Okay, balcony. So let's play around with the plane here, with this polygon plane. So first, when I scale it horizontally, you see my door has a fixed size. And the balcony, the handrail is working. Then I scale it upwards. You see that the window has a fixed size here, and the wall is flexible. And of course, you've seen it before when I changed this this balcony depth with this setting here. The handrail is working as well. What happens when we rotate this? Okay. You see a little bit rotation, and it's already breaking because some of my selection of edges did not work properly. So at some point I did not properly choose the right edges in terms of downwards or forward or leftward. You have to make that right, and if you do it right, then suddenly you can rotate the thing, and the balcony will remain until it flips, to the other side of that polygon, and suddenly downwards is one of the other edges, but it builds the complete balcony in a correct way. So I assume somewhere here in a PPG multicut, this was the balcony. So here probably I didn't pick this one right here, so this probably needs to be the one again. And now when I rotate, you see, now suddenly I can rotate and boom, here's my balcony to the other side. So that's meant with proceduralism. How are we in time? So that's meant with proceduralism. Now let's have a quick look, because we are short in time already. Let's have a quick look at this thing over here, this Washington building from New York. And I want to talk a little bit about, and I can close the Bifrost graph editor because I don't need that one here. I want to talk about the building steps of this thing, because that was something that, you know, caused me a lot of trouble. I had to build this at least 10 times until I found out, you know, what I have to look for if I want to subdivide this thing. I started with this beveled cube here, and I also did some extrude here at the top to, you know, have some offset for a penthouse and some balcony around. And I literally looked at the polygon numbers to give these the face tags that you see here. So the proper way would be, of course, you know, to find some procedural way to assign these names to the respective polygons. So, and then I started with the penthouse, extrude the penthouse out at the top. If I use another polygon for this or other polygon base object, I would have to do an extrude for the roof thing with an offset inwards so that I have my penthouse base that I can then extrude. So another object would mean we need a little snippet of more construction history. The next step would be the roof of this penthouse. I simply couldn't wait. I wanted to make the roof immediately, and also the subdivision for the penthouse itself, so the sides of the penthouse. And then for the building, for the main block of the whole building, when you look at this building, you have to understand, and that's what architects do, you have to understand how is the whole subdivision of this building. Aside from the fact, of course, you need to think or plan ahead which parts will be flexible when I scale the whole thing up and down. You know, where do I insert more floors, or, you know, something like a higher floor or something like that. So I made this subdivision here to say, okay, we have the street level subdivisions with some entrances with these nice marquises, or however you call that in English. And then we have the main body that is subdivided with a strip on top and at the bottom, so 2 new strips. And then again, I'm taking these strips here and subdivide them, or take the body first, subdivide it again, cut another thing off as the ballroom floor, you know, with very high rooms over there. And then I take these 2 yellow strips here and subdivide them to get extra rims around the building. Because when you look sometimes at these buildings here, there are elements there that are not needed for the architecture. They are not needed to make the building stable or something. They are just, you know, nice details on the facade. It's a facade, right? So we make these rims here, I'm calling them rims, and I will extrude them out later to get these, you know, to get this slightly three-dimensional surface of the facade. So I have the strip here and the strip here with 2 rims, and I need another rim here at this line. So I subdivide this one here with a very simple multicut just to add this extra rim here. And then comes the main body is subdivided into floors. And these floors are now, you know, that's the part that scales when I make the building higher. I will get more floors, because this body part was the last remaining flexible part that, you know, will become bigger when I scale the whole thing. And then, you know, that was also something very important. I need one cut through all of these strips. So I'm picking this strip here, the tall, the body win, the strip, and the body street, and do one cut through all of them, because when I make it wider, I want them all to scale in the same way without me connecting the nodes together and doing something artificial. So I do this. And now I think it's the time to open the graph editor and to turn off the labels here, because that's a little bit too much. So here at the end of the construction history, I turn this one off. So right, so here you see the basic structure of the whole thing. Now when I stretch it, I can do all of these. These do have different names here. So these spaces between the apartments, between the windows, all have different names, but I can collect them in the expression. I can say this name, this name, this name, this names. They all got to be extruded, for example. So I'm starting with some extrudes here. So now I extruded the windows. No, what did I extrude here? No, I cut the windows in half. and in the next step, I extrude the windows a little bit in to get some window frame or something like that. And then I'm extruding further, so the next step will be the rims. So here you see the typical three-dimensional structure of a facade, and then here's one more extrude on the top of the balcony, and one more. You know, these vertical strips here can be extruded as well, and the floors itself, that's part of the apartments. And then we start to make instances. And instances are really cool to insert some more complex details that you can't do in a procedural way. So some of these, you know, these arch windows, for example, or when I, or this round one here, when I do the ones on the street level, I found no way to do this procedurally. It would be cool if I had a procedural way to do these. On the other hand, once you have modeled them, you can put them in and they scale with the windows, or you make the windows static with a fixed size and everything else is flexible so that this detail, your instances don't need to be scaled and stretched into place. Okay, so that is the basic thing that we have right now. So I'm looking further into procedural selection. You know, how do I select polygons? How can I choose things by other criteria? More functions here, more things that I can do. So what I'm doing here, let me jump back to my presentation. What I'm doing here is to make packages like this one here with different kind of recipes for the building. So this whole construction history can be collapsed into one function, and you can say, okay, some strategic values I'm pulling out of there and have them available outside of this node here, and there I can adjust, you know, how high are the floors of my building, what's the distance between the windows and that kind of stuff, if you want to play around with that. So I'm just using a few strategic values here, and you see this one here is rendered. So what I did was in Bifrost to assign colors, but it's one shader only. And it renders perfectly, so you can render directly from Bifrost. Let me see if we have another one here. So this one here, about rendering, this is the diagnostic shader with the colors rendered directly with Arnold. So as long as it's a Bifrost object, you can still render it. These ones are the same, but instead of diagnostic colors, I assigned different gray tones for the same shader. If you want a Maya object with shaders, then you would have to reassign shaders. That's the current state of the thing, because the conversion to Maya does not keep the shaders. But for your game engine, you can output different pieces of the building, because maybe you noticed these models are not watertight. So we have long strips of polygons and many windows, but these polygons are not joined together. They are separate pieces. And you can say, okay, all of these face tags, I'm collecting face tags, all of these will have the same material, so I output them as a separate object into Maya. That's relatively easy possible. So far, as I said, it's a thing under construction. You can find it in our forums, in our Autodesk forums. Just Google my name, and let me show you this one here. Just Google my name, you will find my YouTube channel, which describes the whole thing again, you know, some usage advice. And also you will find on our forums at the Autodesk sites the download for this thing. And if there's an update, I will notify you, or you know, you get notified if you follow that thread. I will store a new version always under the same thread so that you get a notification when there's a change in the whole thing. That's it. Thank you very much. Do you have questions?
Thank you very much, Roland. Do you have any questions? Yes?
Hello. Yeah, thanks for the presentation. That was pretty interesting. I have two questions. How you would handle UV mapping in a case like this, and if you could show how one of those nodes look like I want to see the complexity, or multi-cut, or one of those.
Yeah. So
Thank you.
The UVs are a problem, and you noticed, right away what's with the UVs. There would be, of course, a way to maintain the UVs, to say, okay, here's a polygon, I have UVs. If I do a multicut, I simply subdivided the same thing, so I have subdivided UVs. I'm not doing that yet. I was, desperate to get the polygons working and didn't touch the UVs yet. The UVs are a problem for me when it comes to extrudes. What do we do with extrudes? There are methods, of course, to grow the UVs in a different direction because it's 2D. Not yet. So in the first version, UVs are not good. You would have to do an assignment, three-direction assignment of the UVs, since it's architecture. So you wanted to look in one of these nodes here. So we have the PPG multicut, for example. It's not nice what we see here. So it's a lot of complexity when we dive into this whole thing. So there are a few nodes that are necessary. This one here, for example, is the edge selection by certain criteria. And it spits out all of these values like edge vectors, the face centers of faces, if I want to do instancing, for example. So these nodes are used everywhere again and again, and I can dive deeper and deeper into this stuff. So compared to the developers of Bifrost, the developers of Bifrost want to provide the very basic nodes only. Not these huge nodes with 1,000 settings or so. They think like, let's let the users do that shit. We just provide the basic language here with very simple nodes that everybody can use to build their own stuff. But of course, not everybody wants to spend a few months to build such a system here. That's why I made it. And also, of course, because I'm practicing with this thing. I understand Bifrost much better the more of that stuff I build.
Okay, thank you very much.
Any more questions?
Any more? No?
No.
So,
then thank you very much.
Thank you very much, and thank you for today.
Yeah. Thank you.